Today we're going to be reviewing section 2.4, Solutions of Linear Inequalities. Our objectives today are to solve linear inequalities algebraically, solve linear inequalities graphically with the intersection and x-intercept methods, and to solve double inequalities algebraically and graphically. An inequality is a statement that one quantity or expression is greater than, less than, greater than or equal to, or less than or equal to another. A linear inequality, or a first-degree inequality, in the variable x is an inequality that can be written in the form ax plus b is greater than 0, where a is not equal to 0. The inequality symbol can be written as greater than or equal to, less than, or less than or equal to. We have steps for solving a linear inequality algebraically. It's a 5-step program here. We start with step 1. It says if a linear inequality contains fractions with constant denominators, we'll multiply both sides of the inequality by a positive number that will remove all denominators in the inequality. If there are 2 or more fractions, we use the least common denominator, or LCD, of the fractions. Step 2, we will remove any parentheses by multiplication. Step 3, we will perform any additions or subtractions to get all terms containing the variable on one side and all other terms on the other side of the inequality. Then we will combine like terms. Step 4, we will divide both sides of the inequality by the coefficient of the variable. We will reverse the inequality symbol if this number is negative. We will then, for step 5, check the solution by substitution or with a graphing utility. If a real-world solution is desired, we will also check the algebraic solution for reasonableness in the real-world situation. So let's look at an example. This example says the solution of a linear inequality. We want to solve the linear inequality 3x minus 1/3 is less than or equal to -4 plus x. Now, in this inequality, the first thing we see, if we're following our 5-step program, is that we have a variable, or in this case a number, in the denominator. We have a 1/3 fraction to deal with, essentially. Now, we don't want to deal with the fraction, so the first thing we need to do is multiply the entire thing by a number that will get rid of that fraction. So, in this case, we will multiply everything by 3, because that will cause the 3 in the denominator to cancel out, and then we won't have to deal with any more fractions. Keep in mind that we need to do this 3 on both sides, so when I put this linear inequality in parentheses here, it's the same as saying 3 times 3x minus 1/3 is less than or equal to 3 times -4 plus x, because that 3 needs to go to everything. Okay. We will then distribute the 3 to the 3x, we get 9x. We will distribute the 3 to the -1/3. 3 times -1/3 is -1. We will then distribute the 3 to -4, which is -12, and we will distribute the 3 to the x, which is 3x. Now we have a system of linear inequalities here that has no denominators, okay, has no fractions to worry about. So now we just have to look at combining like terms. So first thing we do here when combining like terms is I'm going to subtract the 3x over to the left-hand side. This is going to give us 6x minus 1 is less than or equal to -12. Then I'm going to add the 1 over to the other side to get the 6x by itself. That leaves us with 6x is less than or equal to -11, which brings us right back to this step right here. Okay. Now, to get x by itself, we're going to divide by 6 on both sides, and this gives us that x is less than or equal to -11/6. Now keep in mind, when we have these inequalities, a lot of times we like to write them in interval notation. When we write them in interval notation here, the interval notation for this is parentheses -infinity, comma, -11/6 with a bracket. Remember, we use the bracket on 11/6 because it does have the potential to be equal to 11/6. Okay, so our solution set is -infinity to -11/6, inclusive on the 11/6, -11/6. Let's take another example. Profit. For an electronic reading device, the weekly revenue and weekly cost in dollars are given by R of x equals $400 x equals 200x plus 16,000, respectively, where x is the number of units produced and sold. For what levels of production will a profit result? Okay. Now, in order to solve this problem, we have to have a little bit of common sense here and know that in order to have a profit, our revenue has to exceed our cost. Okay, so a profit will occur when revenue is greater than cost. So we find the level of production and sale that gives a profit by solving the linear inequality. Okay, linear inequality we're going to solve is R of x needs to be greater than C of x. Okay, now we don't do greater than or equal to, because if R of x is equal to C of x, then we haven't made a profit, we haven't made a loss, we've broken even. We don't want to break even, we want to make a profit, so we're setting R of x greater than C of x. Now, what we essentially do at this point is we substitute in the R of x function for the R of x, and we substitute in the C of x function for the C of x. So, 400x needs to be greater than 200x plus 16,000, because the 400x represents your R of x, and the 200x plus 16,000 represents your C of x, which is your cost. Now that we have it in a simple linear inequality here, we can solve for x and come up with our solution set. So I'm going to subtract 200x from both sides. That's going to give me, that's going to give me, thought I had it written on the next step, that's going to give me 200x is greater than 16,000. Then to solve for x, I'm going to divide by 200 on both sides. Okay, zeros cancel here, 160 divided by 2. That leaves me with x is greater than 80. You can use your calculator to do the division and simplification there if you'd like. So, as we see, we break it down, we see that x is greater than 80. Okay, so a profit will occur if more than 80 units are produced and sold. Keep in mind that that means we have to sell more than 80 units. If I sell just 80 units, I've technically not made a profit because it's not equal to 80. I have to sell more than 80 units. So I need to sell 81 units, 82 units, 83 units. Also keep in mind this is a real world situation, so I can't sell half of a unit or a piece of a unit. We're only going in whole units here. So our solution set for this basically includes all whole numbers greater than 80. Let's look at another example. This example involves body temperature. A child's health is at risk when his or her body temperature is 103 degrees Fahrenheit or higher. What Celsius temperature reading would indicate that a child's health was at risk? Now, we know that the degrees Fahrenheit is 103. We also know that the relation that converts Fahrenheit to Celsius is F equals 9/5 C plus 32. So we're going to use that relation to generate this inequality. That relation you're not expected to know. That's a piece of information we would give you. Okay. So we are given this, and we're given that their temperature is at risk if it's 103 degrees Fahrenheit or higher. So if our temperature here, 9/5 C plus 32, is greater than or equal to 103, then our child is going to be at risk. We need to figure out what this degrees is going to be in Celsius. So we need to solve for this C. Now, following my steps here, the first thing I'm going to do is get rid of this 5 in the denominator. So I technically need to multiply everything here times 5. Okay, 9/5 times 5 will cancel out the 5 in the denominator. I'm left with 9C. 5 times 32 is 160. 5 times 103 is 515. So I'm now simplified down to the equation 9C plus 160 is greater than or equal to 515. Then I'm going to subtract 160 from both sides so that I get 9C is greater than or equal to 355. Last step here, I divide by 9 on both sides. That's a 9 there. I divide by 9 on both sides. I get C by itself, so that my answer here is C is greater than or equal to 39.4. Thus, a child's health is at risk if its Celsius temperature is approximately 39.4 degrees or higher. Simple enough. Simple enough. Real world problem there. Now, let's look at steps for solving a linear inequality with the intersection method. Okay, so in this method, we're going to set the left side of the inequality equal to y1, and then we're going to set the right side of the equality to y2. Okay, then we're going to graph the equations on your graphing utility. Okay, we're going to choose a viewing window that contains the point of intersection and find the point of intersection with x coordinate a. This is the value where x where y1 equals y2. And the values of x that satisfy the inequality represented by y1 is less than y2 are those values for which the graph of y1 is below the graph of y2. And the values of x that satisfy the inequality represented by y1 is greater than y2 are those values for x for which the graph of y1 is above the graph of y2. Let's take that in and do an example. Okay, here's our example. 5x plus 2 over 5 is greater than or equal to 4x minus 7 over 8. We're going to use the intersections of graph method. So, in order to use the intersection of graph method, what we're going to do, on your TI, get your TI handy real quick. In y1, you're going to type 5x plus 2 over 5. And then in y2, you're going to type in 4x minus 7 over 8. Okay, so take a second to do that. Put in your y1 on your calculator, the 5x plus 2 over 5, and then put in the y2 on your calculator, the 4x minus 7 over 8. Then hit the zoom button and go down to zoom standard and hit enter. If you do so, you should get a graph that looks really similar to what we're seeing graphed over here on my page. Okay? Now, if you want to find this intersection point on your graph where they intersect, you need to go second calc, intersect, and then you need to hit enter 3 times. Enter on the first curve, enter on the second curve. Then you can move the cursor if you'd like to get close to the intersection curve of the curves, and hit enter a 3rd time, and it will find this point negative 2.55 approximately, and negative 2.15. Okay, so your graphs will wind up looking like this. You have your intersection point here. So when we graph these lines and find their point of intersection, the two lines intersect at the point where x is negative 2.55 and y is negative 2.15. Okay, now this isn't the answer quite yet. Okay, the answer of this problem is when y1 is greater than or equal to y2. Okay, y1 in my case is the blue line, y2 in my case is the red line. So, when is y1 bigger than or equal to y2? When is y1 above y2? y1 is above y2 from this point here. Let me change the color of my pen. Change it to green. So basically from this point here on up is when y1 is over y2. So from this point, this x value on this point, which is negative 2.55, to infinity, that's when y1 is greater than y2. So that, in of itself, is my solution set. Or if I write it as an inequality, it is x is greater than or equal to negative 2.55. Easy enough? Alright, let's solve linear inequalities using the x-intercept method. We will rewrite the inequality with all non-zero terms on one side of the inequality, combine like terms, getting f of x greater than 0, f of x less than 0, f of x greater than or less than or equal to 0, and f of x greater than or equal to 0. We will graph the non-zero side of the inequality. Any window in which the x-intercept can clearly be seen is appropriate, so we need a zoom point where we can see the line across the x-axis. Number 3, we will find the x-intercept of the graph to find the solution of the equation f of x equals 0. The exact solution can also be found algebraically. And we'll use the graph to determine where the inequality is satisfied. Alright, so let's try this example. It says apparent temperature. When the temperature is 100 degrees Fahrenheit, the apparent temperature, A, or heat index, depends on the humidity, H, expressed as a decimal. According to A equals 90.2 plus 41.3H. For what humidity levels is the apparent temperature at least 110 degrees Fahrenheit? Okay, so we need the A, which is the apparent temperature, to be greater than or equal to, because this is at least, greater than or equal to 110. Now we know the formula for A. The formula for A is 90.2 plus 41.3H. So I can substitute that in and say 90.2 plus 41.3H is greater than or equal to 110. Alright? Now, we're wanting to do this x-intercept method that we just talked about. So what we have to do is rewrite the inequality with a 0 on the right side. Okay? So here's what I'm going to do. I'm going to start out by subtracting 110 over here on the left-hand side. When I subtract 110 from 90.2, I get negative 19.8. So my inequality turns into 41.3H minus 19.8 is greater than or equal to 0. Now, I'm going to graph that in my y1. So my y1 is going to look like this. I'm going to go to my TI calculator. My y1 is going to be 41.3H minus 19.8. Then I'm going to graph on a window here. So this is my y1. Let me see. Where'd my cursor go? Okay, it's right here. This is my y1 equals 41.3H minus 19.8. Now, if you notice on my window here, I'm not on a 10 by 10 window. You will probably be able to see this cross the axis on a 10 by 10 window. So as long as you can see where it crosses the x-axis, and I'll do a color that hopefully you can see on your side. As long as you can see where it crosses the x-axis here at this point, then you're good. Okay. Now, we graph the y equals 41.3H minus 19.8. The intercept. Now, in order to find this intercept on your TI calculator, what you're going to need to do is second trace or second calc 0. Okay, and then you're going to have to bound it on the left, bound it on the right, and then you're going to have to guess it on the middle. So basically, bound it on the left, enter, and you'll get a dotted line on the left to bound it. You'll get a dotted line on the right to bound it. And then you'll move your cursor to about where you think it is, hit enter a third time, and it will tell you that this intercept point is approximately, for your x value here, your 0 here, is 0.479. Your y value will be a 0. That is that point. And you can find that on your TI calculator. Okay. Now, the x interval where the graph is on or above the x-axis is the solution. Because keep in mind here, we were looking for it to be greater than or equal to. Okay, greater than or equal to. That's what we wound up here. Greater than or equal to 0. So it needs to go above this axis. Okay, it's 0 right here at this point, 0.479, 0. It's bigger than that. It's bigger than that when it goes above it. It's smaller than that when it goes below it. So our solution set is the 0.49 on up. Now, here's where the real world situation comes into play. We are talking about humidity. Humidity, that's what the whole problem itself is talking about. Now, humidity is rated in percentage. Okay. Now, that percent can go from 0 to 100. But that percent can't go over 100. So, because of that, our solution is going to be limited. So, our solution is going to be limited from 0 to 100. Now, that's just from the problem situation itself. We've already determined that the lowest point it can be is 0.479. Okay? We have to further limit this based on our problem situation because we can't make it over 100%. 100% written as a number is 1.00. So our actual restriction here is 0.479 to 1. Okay, so we can say that the apparent temperature is at least 100 degrees or 110 degrees when the humidity is between 48% and 100% inclusive, approximately. Okay, we round it here and here. So we can say that that apparent temperature is at least 110 degrees when the humidity is between 48% and 100% inclusive. Now, let's look at something a little more fun. Double inequality. represents two inequalities connected by the word and or. Double inequalities can be solved algebraically or graphically. Any operation performed on a double inequality must be performed on all three parts. That's the key there. It has to be performed on all three parts. So let's take this situation and put it in a double inequality. Our example here is course grades. A student has taken 4 tests and has earned grades of 90%, 88%, 93%, and 85%. If all 5 tests count the same, what grade must the student earn on the final test so that her course average is a B? That is, so her average is at least 80% and is less than 90%. Now, how do we set this problem up? Well, there are 5 tests total. All of the tests count the same. We want her average to be a B. That's between an 80 and a 90. It includes the 80, doesn't include the 90. In order to find her average, I have to add all of her grades up. And because she's taken 5 tests, I have to divide it by 5. So, here's what we're going to do. We're going to set this problem up. We want her to make anywhere from an 80 all the way up to a 90, but technically if she makes a 90, she makes an A, so we're not going to put the equal to on the 90. Her current grades are a 90, an 88, a 93, and an 85, and she still has to take a 5th test. So we're going to let that 5th test be represented by that X. And we're going to find the average of those 5 tests by dividing the whole sum by 5. Let that sink in. We're taking the average of her test, adding in her 5th test, which we don't know the score of, so we're putting an X as a placeholder there, dividing by 5 to find the average. When we simplify this, 90 plus 88 plus 93 plus 85 is going to add up to be 356. So all I've done is simplified this piece down to 356 in this part of the problem. Now, the next thing I have to do is I have this fraction I have to take care of. I have a 5 in the denominator. And following everything else that we've done today, we know we have to get rid of this number in the denominator. In order to get rid of that 5, I'm going to multiply everything by 5. 5 times 80 gives me 400. 5 times 356 plus x over 5 cancels this 5 out. That's where I just get the 356 plus x. It did its job, it canceled that 5 out when we distributed it here. And then 5 times 90 is 450. That's where this next step comes from. Now, the only thing I have left to do is get x by itself. And here's the next key, okay? And we kind of did it in the step above. What you do to one piece, you have to do to all 3. What you do to one side, you have to do to all 3 sides. So in order to get x by itself here, I need to subtract 356. And that means I need to subtract 356 from the left-hand piece, the middle piece, and the right-hand piece. I can't just subtract it from one piece, I have to subtract it from all 3. What you do to one piece, you have to do to all 3 pieces. You can't just do it to one piece. You can't just do it to 2 pieces. You have to do it to all 3 pieces. When I do that, I see that 400 minus 356 is 44, which is less than or equal to x, which is less than the 450 minus 356 gives us a 94. So, she will receive, or they will receive, a grade of a B on the final score if their final score is at least 44, but less than 94. So, this is the grade range, 44 to 94. They make a 44, they get their B. They can make up to a 94 and still have a B. Obviously, if they make 94 better, they have an A. Simple enough. Simple enough. Double inequalities. What you do to one piece, you have to do to all 3. If you add to one piece, you have to add to all 3. If you multiply to one piece, you have to multiply to all 3. Double inequalities. Alright, let's look at this example. Expected prison sentences. The mean, or expected time, y, served in prison for a serious crime can be approximated by a function of the mean sentence length x, with y equal to 0.55x minus 2.886, where x and y are measured in months. According to this model, to how many months should a judge sentence a convicted criminal so that the prison or the criminal will serve between 37 and 78 months? Now, the source from this is the National Center for the Policy Analysis. Let's look and see how we break it down. Alright, we want this criminal to serve between 37 and 78 months. Now, this formula here is basically going to be the middle part of our inequality what we're doing here in this first step. We're saying, okay, 37 is less than or equal to 0.558 minus 2.886, which is less than or equal to 78. So we took our equation, we bound it by these months. Okay. Now we're simply solving for x here, keeping in mind that what we do to one piece, we have to do to all three. The first step to this is I need to add 2.886 in order to cancel it out in this middle piece, and then I need to add 2.886 to the other two sides. So I've done it to all three sides at this point. Oops. Let me fix that one. Well, it's supposed to be a 3, it was supposed to be a 2. 2.886. Alright, so that gives us 39.886 is less than or equal to 0.55x is less than or equal to 80.886. Okay. Then we need to get x by itself. To get x by itself, we need to divide by 0.55. Remember, what we do to one piece, we have to do to all three. So I'm going to divide by 0.55 on the left, middle, and right-hand sides. Now when I divide 39.886 divided by 0.55, I get 72.52. I don't expect you to do that division by hand. By all means, use your TI calculator to do that division. So I'm left with 72.52 is less than or equal to x is less than or equal to 147.07, which is what we got when we divided 80.886 divided by 0.55. Thus, the judge could impose a sentence of 73 to 147 months if she wanted the criminal to actually serve between 37 and 78 months. Okay. Essentially what this example is showing is how to use the double inequality mathematically, but it's also showing us in the real world situation that typically when judges assign sentences to criminals, they don't serve the entire sentence. So what the problem's trying to analyze here is how long a judge needs to make the sentence in order for the criminal to stay in the jail for an actual certain amount of time. Okay, so if she serves or imposes a sentence of 73 to 147 months, this means the criminal is going to actually serve somewhere between 37 and 78 months. Okay. That concludes chapter 2.4. If you have any questions, please don't hesitate to reach out to me by email. Let me know. Give your homework and your quizzes and stuff on my Math Lab a try. And like I said, if you have any questions, don't hesitate to reach out. Other than that, I will